Congratulations on your purchase of a Triton Work Centre. We believe you've bought the best value for money woodworking machine anywhere in the world. If you set it up properly, use it according to the instructions, and give it some occasional maintenance, it will look after you for years to come. This video is being made in May 1987. Now, it is possible that the machine which you have is somewhat different to the one being shown here. In that case, please use the manual which came with your machine, because it is specifically for the product you've bought. We as a company have a policy that whenever we design a new product or improve an existing product, we try wherever possible to make the new products or parts adaptable to earlier machines. So if you do have an earlier machine, please contact us, either direct or through your stockist, quote your serial number, and we'll be able to send you out some information on how to upgrade your machine. Our name, address and phone number are printed on the rear panel, as is the serial number of your work centre. We do recommend that you work your way through this video practicing all the cuts you'll see on some scrap wood. However, you won't be terribly popular if you bring your work centre indoors and do it in front of the TV set in the lounge room. Nor should you take your VCR and TV set out into the workshop unless you take some precautions against dust contamination of your heads and your tapes. Preferably, watch the video all the way through in one hit if you can handle it, taking notes as you go of the footage counter of your VCR for each particular segment. And then, when you're ready to do some cutting, you can quickly spool back, have a quick refresher course, and then go out into your workshop. Your Triton Work Centre will be capable of exceptional accuracy, provided it's properly set up, and provided also that the tools you've fitted, the saw, the router, and the blades and bits, are up to the mark. I don't propose in this video to cover the detailed assembly procedures. They're amply covered in the instruction manual, but I do want to cover some of the key points you should look for in assembling the machine and in operating it. First off, make sure that your work centre is securely mounted at a comfortable operating height. If you have an uneven floor in your workshop, use some packing under one or more legs of the Triton stand, or you may want to obtain from us some of these adjustable feet, which are now available to fit to your folding stand or to your extension table. In assembling the basic frame of the work centre, make sure you've got all the nuts and bolts in the correct way as per the instructions. Also make sure that the chassis is basically square, and the best way of checking that is to use a tape measure or a ruler and measure from outside corner to outside corner, and then compare it on this side, outside corner to outside corner. Those two measurements should be more or less the same, give or take a couple of millimeters. It is possible to slightly knock the chassis out of alignment when removing and refitting it to the folding stand, unless you do it the correct way. And the correct way is this. Firstly, remove the table. It reduces the weight and improves visibility. Secondly, always start at the end which has these bracing straps. Then put your foot in here, grab hold of both T-handles and pull up equally with both hands until the rubber feet come out of the tubes. Then move around the other end and repeat the process, trying not to skew the chassis as you lift it up, and then you can remove the chassis, fold away the stand. Vice versa, when putting it back together again, start at the braced end and finish off at the loose end. The rubber feet should be a snug fit in the tubes of the stand. If they're too loose, tighten up the rubber feet a little more, that'll swell them slightly. If they're too tight, back them off a little bit, loosen them off, or lubricate them. You've seen me using the plastic T-handles to lift the work centre out of the stand. Now you can do that, but only if the T-handles are nice and tight. Otherwise you might marginally shift your table position as you lift. Alternatively, you can put your foot in here as before and grab the work centre underneath and unplug it that way. If your basic frame is substantially square, then both of the locking keys should go in equally easily. Now take a fine point marker pen or a sharp pencil and fill in the letters stamped in the table as a reference point until you're more familiar with the different table settings. Now check the action of the slide chassis. Make sure it's a nice firm fit and yet free to slide all the way along. If necessary, use some spray lubricants such as RP7 or WD-40 or silicone and spray the open faces of both channels. When you receive your work centre, the slide chassis is adjusted for its minimum length. That may be okay for some 6.5 inch and 7.25 inch saws, But if you have a larger saw with a longer base, you may have to lengthen the chassis. That's done by removing these two nuts, perhaps relocating their bolts, and extending the chassis until the saw base can fit neatly between the vertical walls of the slide chassis. Just before tightening up the nuts again, check that this dimension and this dimension are the same. Then you can tighten up the nuts and fit your saw. Fit these saw clamping brackets as per the instruction manual, but just a couple of quick points. One of the lower saw locating brackets has a beveled corner, and that goes at the right-hand front corner of your power saw so that it can just miss this ledge. That only applies if you have a larger saw or with a wider base. Now at the rear of the saw, right-hand rear of the saw, you may find, especially with smaller saws, that when you angle the saw to 45 degrees, the top guard of the saw fouls on the bracket. Well, if that's a problem with your saw, then remove that bracket completely and replace it with this small hook-over clamp. This particular saw has a locking lever at the back here to lock the blade angle. Now, because that locking lever wouldn't normally clear the upstand of the slide chassis, I've had to introduce a gap between the end of the saw base and the upstand of the slide chassis and glue or screw a packing piece in there to prevent the saw ever sliding back on the chassis itself if the clamps loosen. This method of putting a packing piece in there is also needed if you've got a saw which has a very short base at the rear and the saw blade is in danger of actually hitting the slide chassis when you turn the saw by hand. Because I've introduced that gap, the radius on the edge of the saw base there would foul the normal use of the hook-over clamp, so I've notched out that corner there. If your saw has a fairly small wing bolt on the back, then an alternative to introducing the gap and the spacing is to file a small relief in the die-cast chassis, provided you don't have to go down more than 1/3 of that height. Finally, on the clamps, if you have a protrusion on the base of your saw that prevents you properly fitting one of the top clamps, remove the protrusion or hacksaw a corner out of the clamp. It's quite safe as long as you've got a fairly substantial amount of support on the saw base itself. Now attach some wire or string to the actuating arm of your saw guard and tie the guard back. Even though you don't use the saw's guard on the work centre, don't remove it altogether. You may one day want to use the saw handheld, and a saw without a guard is extremely dangerous. For the same reason, don't leave your guard permanently tied back. At the end of each day's work, release the guard and let it go back to its relaxed position. Otherwise, the spring will fatigue, and again, if the saw is ever used handheld, the guard will be worse than useless. Just a couple of quick points on fitting your saw blade. Firstly, before fitting the blade, make sure you've cleaned all the accumulated sawdust and resin from behind the saw blade on the arbor washer. Then fit the blade, tighten the arbor nut, but don't over-tighten it. Also, make absolutely sure you've got the blade on the correct way around. People often put them in back to front. The teeth must be cutting upwards into the wood when the saw is going around in its normal anti-clockwise direction. Don't be misled by the manufacturer's brand on the saw blade. As you can see from this example here, two brands on different sides of the saw blade. You can sometimes buy wobble washers, or dado washers they may be called, or a trenching head for your power saw. That effectively makes the saw blade wobble during a cut, giving you a wider cut. We do not recommend it. It'll wear out your saw very quickly and could damage the Triton table. Make sure your saw blade is set at maximum depth of cut, and then adjust the table upwards until the tips of the blade teeth are just entering the slot in the table, just a millimetre or so below the surface. Check it at this end, slide the saw at the other end, and check it at the other end. Now, you will see later in this video that there are occasions where you have to lower the table for cutting a thick piece of wood. You should very rarely have to raise the table, but if you ever do, make absolutely sure before doing your next cut that you've reset it to the correct position. Otherwise, the blade going too far into the slot can cut into the subframe bar underneath the table. Almost all power saws suffer from something we call saw slump, and that is the ability of the saw motor and blade to flex in relation to its base shoe. Now, with a higher quality saw, the saw slump is almost negligible. With a cheaper saw, it can be quite severe and cause inaccuracy in cutting. There are a few ways you can rectify the problem. Firstly, try to tighten up your own saw by checking the front pivot bolt and the rear pivot bolt. You may have to tighten the bolt and nut, you may have to put some shim packing in, You may even have to drill out a rivet and replace it with a bolt and lock nut. If you have a conventional type of saw, not a vertical lift saw, you may find if you've got excessive saw slump, it may be due to a small gap between the saw body and this bracket at the front. Well, that's fairly easily fixed by making a shim out of some thin sheet metal, say a soft drink can cut up, and remove that bolt, put the shim in, and then put the bolt back in. The other potential trouble spot for conventional saws is at the rear of the saw, where you may have a rivet through there, which has become sloppy with age. Drill the rivet out, put a bolt and lock nut in its place. It's generally not possible to completely tighten up a power saw, and so you may find, especially when converting from the table saw mode to crosscut mode, that there's a very slight shift in the angle of the saw blade to the table caused by the weight of the saw motor. There's an easy way of fixing that. The first step is to convert the work center to the table saw mode, because in this mode the table is not adjustable. Then use the adjuster on the front of your saw, the wing nut adjuster, to raise your blade until the blade is square to the table. If you're having trouble getting your saw blade square to the table, you may have to file a small amount out of the end of the slot in the quadrant of the saw, or failing that, you may have to place some very thin packing between the right-hand side of the saw shoe and the saw chassis, and that'll effectively tilt the entire saw over very slightly. Having got the saw blade nice and square to the table, now convert to crosscut mode. Follow the test cut procedures in the instruction manual and do a shaving cut on the end of a straight piece of wood. You'll probably find that along the cut you've got a perfectly square result, but across the cut you might find that there's a slight error introduced by the saw slump. Now, in the crosscut mode, the table is adjustable, so you don't have to fiddle with this wing nut on the front of your saw every time you convert between modes if you've still got a little bit of saw slump. What you can do is build a slight compensating slope into the table by lowering the left-hand side of the table, front and rear, by up to 4 or 5 millimeters to allow for that saw slump. If you've been unable to tighten up your saw adequately, you can obtain from us or from your Triton dealer a saw stabilizer bracket. Now, this bracket fits onto any power saw and very simply gives you the ability to lock the motor in relation to the chassis. For example, here we've got a lot of slump. The minute I tighten this knob, it's tight. The bracket also works when you're raising the saw blade for a partial cut. Slump removed. And when you're doing a 45-degree cut or any other bevel cut, the bracket tracks around with the saw and enables you to lock the motor firmly in position. With most saws, the trigger strap can be set the correct diameter by pressing this little nib here and setting it in the appropriate ridge in the strap. And then you can simply slide the trigger strap onto the point of the trigger and it should stay there quite happily. Before fitting the trigger strap, always make absolutely sure that the power to the saw is switched off, and preferably that the saw is unplugged. If the trigger strap tends to slide about on the shiny handle of the saw, then glue some sandpaper onto the back of the handle to give you some extra grip. If your power saw has a safety lockout button, push the button first, pull the trigger, and then slide the catch into position. If you're having problems with your trigger strap and you can't solve them in any of the ways just mentioned, you can obtain from us this Velcro type tape, hook and loop type tape, where you can slip it around the trigger, lash it firmly in position, and hook the tape onto itself. When converting to table saw mode, it's essential that one of these two lugs underneath the table locks the chassis in position and stops it from sliding. Your work center may not have lugs like this. It may have spring catches. They perform the same function, but the way you use them is a little different, so consult your instruction manual in that case. The lug has to fit in the slot in the chassis. Under normal circumstances, you use the rear lug, the one furthest from the front panel, but you use the front lug when you're doing reverse angle miters or short taper ripping, as you'll see later in this video. Lock that securely in position, make sure the chassis cannot move, and then when you're happy with your position, remove the table and make some scribe lines on the bearing channels there and at the front position there, so that you can always line up your saw chassis prior to fitting the table. The next step, truing up the saw, is probably the most important step in terms of getting accuracy out of your work center. If you followed the instructions correctly, by the time you get to this point, the saw will only be loosely clamped onto the slide chassis. Okay, first make sure that the blade is exactly square to the table. Then set the fence in its slots, lock the fence off at 0, and then by reaching underneath and pulling, pushing or twisting the saw, you can adjust the saw until the teeth of the blade are just scraping lightly against the fence. Still free to move, but lightly touching the fence front and back. Next, fit the riving knife and safety guard behind your saw blade. There are 3 positions for the clamping bolt. The central position is for most saws, the forward position is for very small saws, the rear position is for very large saws. The idea is to get a gap of about 12 millimeters or half an inch between the back of the saw blade and the leading edge of the riving knife. Here's a very important point. Whenever you're fitting your riving knife, make sure your saw blade's at full height. See, at the moment my blade is not at full height. If I raised it, I'd be cutting into the riving knife if I accidentally switched on the power. So set the riving knife when the blade is actually at full height and you'll avoid problems. Now take 2 short straight pieces of wood and place them on either side of the blade until they're neatly touching the blade on both sides. Check that the riving knife fits within the gap between the 2 pieces of wood. It's not essential that the riving knife be central in the gap, but make sure it's clearly within it. If you have an ultra-thin slitting blade, you may find that even though you've got the saw blade touching the fence when the fence is set at 0, the riving knife and the blade are no longer in line. Well, what you have to do there is adjust the saw clamps so that you can move the saw slightly away from the fence, get it in line with the riving knife. That will, of course, introduce a small error in the calibration scales of the fence, and you'll just have to allow for that when setting up the fence for cuts. Check either visually or with a square that the riving knife is exactly square to the table, and also check that the nose of the riving knife is not sticking up proud of the table. It must be slightly below the surface. If it's not, file it down a little bit. Double check that the fence locks properly. Lock it off firmly at any position, and then push or pull quite firmly at both ends to make sure the fence is securely locked. Incidentally, some lubricant inside these threaded tri-knobs will help in making them twirl up easily. Then check that the safety guard rises and falls freely. Again, you may try some lubricant on the riving knife or some talcum powder perhaps. And check that the miter gauge, the protractor, is a nice, firm, smooth slide. Again, lubrication on the aluminium strip, and check it all the way through its range. If it's tight at any one point, the best thing to do is to take a file or some sandpaper, remove the table, and remove a little bit of the epoxy coating off the walls of the slot to make it free at that point. If it's loose all the way along, the instruction manual will show you how you can spread the strip underneath very slightly to make it a tighter fit. If it's tight all the way along, again the manual will show you how the jaws of a vice can squeeze that strip in slightly. Make sure the slide chassis is locked firmly in position, the saw guard and riving knife clamped down to the table, the blade is free to spin and not touching anything, and then you can switch off the power, just bump this red plate, plug the power saw in, and you can test out the switch and the trigger strap. Switch on. The first thing to look for in selecting a new saw is blade diameter and depth of cut. For you see, in the table saw mode, there is some loss of depth of cut, which means that a 7 1/4 inch saw, if it's fitted with a 7 1/4 inch blade, not a 7 inch blade, will just make it through some 2 inch dress material in the table saw mode. For that reason, we generally recommend that an 8 1/4 inch saw or slightly larger, 9 1/4, is advisable. The next thing you should check for is arbor float. Now that's the ability of the saw blade to move sideways on the main shaft. The way to check for it is to either grab hold of this nut and see if it moves in and out, or pull the whole saw blade and see if it moves in and out. You should look for a tight saw. Now look for a saw which has accessible knobs for locking or adjusting the saw blade, front and rear preferably. Make sure the knobs are easy to get to and lock firmly. The saw itself should preferably have a fairly stiff base, not subject to flexing, and it's not important whether the saw has a riving knife or not because the work centre has its own. We generally do not recommend vertical lift saws because of their difficulties in plunge cutting, and also some vertical lift saws, especially when they're raised, are quite wobbly on their base, except if they've got a rear support bracket or the Triton saw stabilizer bracket. In selecting a saw blade, perhaps the first thing you should ask, should I get a tungsten carbide tipped blade or not? Well, the answer from our point of view is clearly yes, you should. For the following reasons: carbide tipped blades cut much cleaner and faster. They give a smoother, less splintered cut, less ridging on the cut. They stay sharper much longer, between 50 and 200 times as long as a pressed metal blade, and they are resharpenable, so if you do ever blunt a carbide tipped blade, by all means get it sharpened. The next question is the number of teeth you should get. Now, as you can see, there's a wide variation. Here's a 60-tooth blade and a 24-tooth blade. Generally speaking, if you can afford two blades, then get a finer blade for doing your cross-cutting and a coarser blade for doing your ripping, because when you're ripping especially, the gullet behind each tooth has to be fairly large to accommodate the sawdust or swarf that's created. And in ripping, the swarf is in long curls rather than short pieces, so you need a fairly large gulleted saw, or you have to adjust your feed rate accordingly. If you've only got a fine blade, a fairly fine blade, you can use this for ripping, but don't try to overload it, don't feed the wood too fast. Another consideration is the thickness of the saw blade that you're getting. Now, as you can see from this example, you can get thin blades and you can get thick blades. The thin blades, or slitting blades, are recommended when you're working with a saw which has some saw slump, some movement between the motor and the saw base, because the thin blade has less load on it, it's removing less material, and any inaccuracy in your saw is less likely to show up. If you've got a tight saw, however, a thick blade is better, because it won't tend to wander with the grain, it'll cut straight, plough its way through rather than deflecting during a difficult bit of cutting. We generally don't recommend the use of arbor reducing washers unless they're a perfect fit in the saw blade. As you can see here, there's a step between the washer or the bush and the blade. That can cause a problem. If the bush is too tight, it'll cause the blade to buckle. If it's too loose, it can cause eccentricity in the blade. If you are using a reducing bush, make sure the washer, the flange washer which clamps the saw blade onto your power saw, is bigger than the bush you're using. Having decided basically what sort of blade you want, how do you pick the better quality blades from the worse quality blades? Well, there's quite a lot in it, but here are a few quick pointers. Firstly, look for a saw blade that has as its basic disc hardened steel rather than a mild steel. And you should tell that from the packaging of the blade. If they're using hardened steel, they'll boast about it probably. Secondly, look for grinding marks. Look for signs that the blade has been ground on both sides. And look closely at the teeth, and you should be able to see very faint grinding marks on all the sides of the teeth to make sure that they've been surface ground, both sides. And the better quality blades, the teeth are also ground on the tops and on the faces themselves. So again, look for those little scratch marks. Now, some of the better quality blades have expansion slots in them, and those expansion slots allow the saw blade to heat up slightly during a cut without buckling, because any increase in circumference is taken up by the slot itself. Similarly, the better quality blades after saw doctoring are tensioned. They have a tension ring knurled into them, and that again helps the blade stop deflecting during a cut. Now, whatever blade you decide to get, check through the range available in the store and check it this way. Get a straight edge, take the blade out of its packaging, and check with the straight edge across the centre at various points that that blade is dead flat. Check it at several points and make sure. Now, that is very important, so check it, because some blades from brand new aren't quite right. If for cost reasons you've decided you can only afford one high quality blade, then you may have to compromise on the number of teeth. As a rule of thumb, a 7 1/4 inch saw should have about 30 teeth, an 8 1/4 and 9 1/4 inch saw 40 to 60 teeth. One last thing about saw blades: keep your blades in good condition. This blade was taken off one of our customers who complained that his Triton wasn't cutting accurately. Well, the answer was quickly identified. The blade's rusty, it's not flat, it's buckled, and there's not a single carbide tooth left on this blade. Every single tooth has been smashed off. No wonder he couldn't cut properly. So with your saw blades, keep them clean, keep the resin from accumulating on the blade and wash it down. Mineral turpentine and steel wool is a good combination to get the resin off the blades. Look after them, keep them sharpened regularly, and if you lose a tooth or two by hitting a nail, for example, get it re-tipped. It's not expensive. A lot of people don't know how to check a tri-square. Now, here's a very simple and infallible method of checking it. get yourself a board with a nice straight edge. That edge has to be absolutely straight, so check it first. Then place your square hard up against the straight edge, use a sharp pen or pencil and draw a line. Then turn the square over, hard up against the edge again, and compare the blade of your square with the pencil line. If they're exactly parallel, then your square is absolutely accurate. If they're not, any error in your square will appear as doubled because you've turned the square over. And if you're going to the hardware store to buy a new square, I suggest you take a board with you and a pen or pencil and test the ones they've got in stock, because a lot of squares from brand new are inaccurate. Most of the jigs used in this video have been drawn up by us and are available in plan form in the Triton project book. Just before starting work, a few quick safety points. Firstly, always work in a well-lit and uncluttered environment. Avoid scraps of wood underfoot, piles of sawdust and tangled power cords. You could trip. Secondly, protect your eyesight. Wear safety glasses, preferably the wraparound type. If you're working in natural light or a mixture of natural and artificial light, then use a clear type of safety glasses. If you're working purely in artificial light, the amber tinted glasses will give you better contrast. You should also consider getting a pair of earmuffs, especially when using the router for sustained periods, because the sound of the router can damage your hearing over a long period of time. And a dust mask, very cheap, very easy to obtain. Wear one of these whenever you're cutting tiles or bricks, and there are certain types of wood that you shouldn't cut without using a dust mask. The problem with certain types of wood mainly comes up when you're sanding them, creating very fine dust particles, or burning the wood. But here are some of the materials which can give you problems if you inhale the sawdust or come into contact with it. Black bean, silky oak, cypress pine, some species of mahogany, blackwood and spotted gum. Pine treated with copper chrome arsenate can be a health hazard if you sand the material over a prolonged period or burn the offcuts or the sawdust. You should declare your workshop off limits to children and pets. They could disturb you during a cut and cause an accident, or they may gain unauthorized access to the workshop when you're not there and also have an accident. So for that reason and for another couple of reasons, when you're finished working for the day, disable your work center. Release the trigger strap. That will prevent the spring in the trigger from fatiguing, and untie your safety guard and allow it to swing back to its fully closed position at the end of the day. Again, that will protect the spring in the safety guard. You have the choice in this mode of operation of either using the trigger on the saw or not using it. Using it, naturally, you leave the power permanently switched on and you just squeeze the trigger when you're ready to cut. However, we do recommend that you switch the power on the machine off, switch off at the switch box, use the trigger strap to lock the trigger permanently on, and then control the power from the switch itself. The reason for doing this is that very often, and somewhat unconsciously, people do twist their saw when they're pushing it forwards and backwards. They twist their saw as they're grabbing the trigger, and so it's generally better to leave it locked off and just slide the saw by holding the rear of the slide chassis safely well away from the blade, and you can control the saw's traverse without worrying about whether you're twisting or not twisting the saw. Most people are used to using a power saw in their right hand and holding the wood in their left hand. Quite the opposite is the case with the Triton. You hold the wood with your right hand against the fence and you push the saw with your left hand. Because basically with a power saw on a Triton, you really only need one finger to push it. So use your stronger hand, the right hand in most cases, to hold the wood firmly. One of the best ways is to bunch your fingers together and push on the back edge of the wood, the edge closest to you, and push it down and forwards into the workstop. And that way you can hold the wood. You may prefer to wrap your hand over like that, but make sure that your thumb doesn't protrude too far underneath the bearing channels. In fact, as a good rule of safety, try to keep your hands outside the bearing channels at all times. It's very important, if you want some accuracy in your cross-cutting, to work with very straight pieces of wood and make sure that the face which is held against the workstops, these two workstops, is absolutely straight. Hold it down there, make sure there is no sawdust between the wood and the work stops, because of course that will hack the work out from the work stops. Press it firmly down against the table and against the stop, and then you're ready to make your cut. Another word of warning in your selection of material: try to avoid cross-cutting or indeed ripping through any knots, because a loose knot like this especially can shatter during a cut and a piece could fly out and hit you or get you in the eye. The next step is cutting accurately to a line. Okay, well, mark a line on the face of the piece of wood you want to cut, and let's call this small piece the waste piece. Obviously you don't have to square your line all the way around, just one face will do, or even just a simple mark will do. Place the wood in the work centre with the straight face against the work stops, and have the pencil line roughly halfway above the centre slot in the table. Now you can open this side guard here and move the saw in until the blade is just touching the line. Turn the blade around if necessary until the tooth is just at the right spot, and then move the piece of wood in sideways, inch it in until the blade appears to be parked perfectly on the waste side of the line. Now there's a very important point here. You must never switch on the power while the saw blade is touching the piece of wood in any mode of operation. Always back the saw off slightly until you're well clear of the wood before switching on the power. Now give the saw a brief burst of power, and as the saw is coasting to a halt, you can do a little test nick on the edge of the piece of wood, just like this. Hold the wood firmly, don't move it. As you can see there, the saw cut is exactly on the waste side of the line, and now without moving that piece of wood, I can now go through on full power and make the cut. If I wasn't happy with the position of that test nick, then of course I could marginally adjust the wood left or right slightly until it was in the right position and then make the cut. In making this cut, I'm going to be creating a smallish offcut, but not too small. That's sitting beside the side of the saw blade. Now that can have very serious safety implications, so have a look at what I do. I made the cut and then allow the saw blade to stop spinning while the saw is parked in its fully extended position. If I hadn't done that, this offcut may have vibrated slightly sideways and the back of the blade may have smashed it when I was pulling the saw back, still spinning. So get into the habit right now of never pulling a spinning saw blade back onto an offcut. Generally speaking, you should try to avoid situations where you'll be creating an offcut of this size. If you're doing test cuts, for example, just take shaving cuts off. Just take off one blade width or a little more than one blade width, and the paper-thin shaving won't cause you a problem. Having said that, you may see me from time to time in this video doing what I've just told you not to do. In other words, pulling the saw back on an offcut. I'm taking a risk because I'm trying to save a bit of time in explaining these cuts, but don't do it. Get into the habit now of never pulling back a spinning saw blade onto an offcut. A couple of very quick points about your feed rate. You shouldn't jerk the saw into the wood. You should push it smoothly and evenly all the way through, and of course never force a dull blade to cut. Get a sharp blade. Apart from the feed rate, there are a couple of other ways you can minimize splintering. Firstly, in the crosscut mode, have your good face downwards, because splintering is greater on the face which is uppermost. So turn your work face down, and secondly, have some backup at the point where the blade cuts through. And the backup is best achieved by having a straight piece of wood screwed to your work stops. And you've got screw holes in the work stops, and just get any straight parallel-sided piece of wood, screw it on, preferably a wide piece. You'll see this is quite useful for a few cuts. But also, the very fact that having the wide piece in there on your work stops means that the work is brought that little bit closer to you, and it does minimize a bit of back strain when you're cutting continuously. The very first cut you make through here will turn this into two separate pieces of wood, both screwed to the work stops, and will give you an excellent sighting point for future cuts, like this. Now you can take any piece of wood which has been marked, place your pencil marked piece right against the edge of the slot, and you can sight up your cuts beautifully simply without looking down through the guard. One important point not covered yet is support for your workpiece. Up until now I've been cutting nice short pieces of wood, but what happens if you're cutting something very long? Well, then you must support the pieces which are hanging out of the work centre. If you don't, once you've made the cut, they will drop, perhaps damage your work centre, and certainly can pinch against your blade and damage your saw blade. So make sure you've got good support for your workpieces, especially long ones. The Triton extension table is an excellent way of supporting them. You can either have the extension table clamped up alongside the work centre, or you can have it freestanding as far away down your workshop as it needs to be, depending on the length of your workpieces. Another method of supporting long beams in cross-cutting is to make up a trestle like this. You'll see more of this trestle in the table saw mode, where you'll see how to use this top surface for supporting large sheets. But at the moment we'll be using this member here, which you should make adjustable up and down, because you might not always be cutting material at the depth of cut of your saw. You might one day want to cut some 4x4 or 6x6 even. So make this either clampable or adjustably screwable. And as far as the base of it goes, you may, if you've got a small workshop, you may want to consider hinging that and making two demountable props so that you can store it more easily. And now you've got excellent support for your long beams during a cut. One of the most useful cuts you can do with the work centre in this mode is to multiple cut. Now, every table has 4 legs, and of course you want them all exactly the same length. So how do you cut 4 pieces or 6 pieces to exactly the same length? Very simply. Cut them a little bit longer than you'll need, and then get your dressed ends, the ends you've just cut, which are nice and square, and have them dead in line on the outside of the machine, like this. And you can tap them into position and just run your finger along there, or use the back of your square to make sure they're exactly in line. Okay, now I find that ducting tape like this is much better than masking tape. It's not very expensive, it's much wider, and it's got good adhesive on it. So once you've got your 4 pieces in line, tape them together, just like so, without moving them. And then, of course, the 4 pieces will act as though they were one piece of wood, and when you cut through them, they'll all be exactly the same length. Clear the table off. It's very important that you have nothing on the table except the wood you're going to be cutting. And then you can move the 4 pieces taped together into position, do another test cut if you wish, so that they'll all be exactly the same length and exactly the right length. Sight that up, that looks fine, and then through you go with one cut. And there you have 4 table legs, all exactly the same length. Say you need 8 pieces the same length. Well, take one of the pieces that you cut in your first batch, and this is the correct size that you want to end up with, and call that your master. Rough cut another 4 pieces, for example, as shown earlier, line up the dressed ends, and tape them together so they move as one block. Then put your master in, and line it up also with the outside end, so that the dressed ends are dead in line, all 5 of them this time. Move the saw in until the saw blade is exactly opposite the 5th piece, the master. And then you can slide the whole lot sideways until the master just touches the saw blade. Make sure you're not deflecting. Pull the saw back and move it in. Back it off slightly if you have to. A whisker. That feels just right. Then remove your master, put it aside, and you can cut your other 4 pieces to length, exactly the same length as the master. Another good way of cutting a number of pieces the same length, especially fairly short pieces, is to use the rip fence that comes with your work centre in the 2 slots. Now you have to turn the rip fence around to fit it in the slots and still keep the work stop in position, but that's fairly simply done. Bear in mind also that the calibration scales are used only to make sure the fence is parallel, because they won't give you a real dimension. Now, in this sort of cut, it is absolutely vital that you don't pull the saw blade back on the wood while it's still spinning, because you'll have 4 small offcuts, and these are the pieces you want to keep. You're making a breadboard, for example, and you want these 4 pieces, so do not pull the saw back onto them. Let it stop once you've finished the cut. Once the saw has finished, you can remove the pieces. There you are, they're as good as gold. They may suffer some very, very slight recut damage because they're sitting against the side of the spinning saw blade, but that's very easily sanded off. And of course, all pieces cut this way will be exactly the same length. You can also get an excellent result cutting a number of short pieces to length in the table saw mode. You'll see that shortly. But it's the mode you should use if recut damage by the side of the spinning blade is causing you a problem. A very useful length gauge you can make yourself is made like this. A straight piece of hardwood preferably, screwed to both work stops, and then the first cut you make will give you a permanent sighting point for future cuts. You line up your pencil mark with that point. However, if you make this gauge properly, you don't need pencil marks anymore because you can glue a self-adhesive ruler on the top, or you can rebate a metal ruler or a wooden ruler into the front, whichever you prefer, and then it's a permanently accurate length gauge. All you require then is a small block where the end grain of this piece is flush and perpendicular to the edge of this piece. Then the block just sits on there and can be G-clamped in position to give you the exact size cut you want. Now you may find that this length gauge won't go back into the same spot if you do remove it and refit it from your work stops, because the holes provided in the work stops are probably slightly larger than the screws you'll be using. Well, there are 2 ways of zeroing your gauge once you've removed it and refitted it. One of them is to loosen off the screws and push the gauge slightly sideways until this edge just touches a saw blade, and then tighten the screws. Alternatively, you can drill a very small hole or perhaps a couple of holes in the work stop, drive a nail part the way in, and then snip off the head of the nail, and that will act as a permanent dowel for removing and refitting. An extremely useful construction joint is known as a trench, or a housing joint, or a dado, depends on which country you come from. And basically, it's just a slot cut crossways across the grain in a piece of wood to house another piece into it. It's very strong and very simple. Here's how it's done. Firstly, you have to raise your saw blade. Don't lower the table, raise the blade using the adjuster on the portable saw. Now, you don't have to crawl underneath with rulers to try and measure the distance that you're raising or lowering the blade. There are a couple of very simple ways of doing it. Firstly, a simple pencil mark on the end grain of the piece of wood you'll be using, or an offcut of that piece, placed in there. Then you push the saw in, and you lower the saw blade until the lowest tooth is just up against the pencil line. Perfect, that's set. There are a couple of other ways. Firstly, using a piece of the wood you'll be using for the job, set the blade approximately to the halfway point, make a cut, turn the wood over, and make a second cut, having moved the wood across very slightly, say 3 or 4 millimeters. When you reach the point of blade adjustment where those 2 cuts would just meet if they were in line, that is your halfway point. There is another way as well, and that is to make up a simple setting block where you have a square dress block with a couple of rulers, or perhaps just one ruler, metric and imperial we've got on this one, but rulers rebated in where the 0 position is flush with the bottom of the block, and then of course resting this on the table will allow you to set your saw blade height to a known dimension above the table. Now there's another very useful feature once you've set your saw blade height of using the Triton for rebating, and that is you can do 2 or 4 pieces at a time. Tape them together if you wish, or if you're only doing 2 pieces and they're reasonably narrow, here's a very good little tip. Take your pieces and take a parallel-sided piece of scrap material that's fairly thin, thinner than the work pieces you'll be using. Place that against your right-hand work stop. That brings the work a bit closer to you to eliminate backstrain. And it also enables you to hold the pieces on the table. Oops, I've got something rocking there. Hold the pieces on the table, get the ends dead in line, and actually wrap your hands around the two pieces and hold them firmly so you don't have to tape them. Then you can line up your cut as shown earlier, touch the saw blade against the pencil line that you've made, do a test nick if you wish, like this. Just adjust very slightly. Perfect. As you can see, by doing the two pieces together, I've created two identical rebates or dados or trenches. They're the same depth, the same distance from the end, and the same width. And if I'd had four pieces in there, I would have done four identical pieces. You don't have to measure and mark each time, just mark the defining cuts of the piece closest to the saw blade. You don't even have to do that, as you'll see in a moment. But now an important hint when rebating. Try not to make your rebate too loose when you start off, because you can always open it up a little bit. It's a bit more difficult to close it down. So do a test fit when you're close to the position that you think you need to be at. Yes, that's a little bit on the snug side. So here's how to open it up very simply. Put the pieces back into the work centre, clearing the sawdust away. Put the pieces back. Park your saw blade in position in the trench you've made, and push the wood sideways until you're slightly deflecting the saw blade, just very slightly deflecting it. Then pull back. When you come through under power, you'll now do a finishing cut, and you'll just skim off a small amount, widening the trench slightly. There we have it, a perfect fit. Incidentally, a very excellent joint you can make is called a post and rail joint, where those two pieces are glued face to face, and then of course a rail can fit in there beautifully, and you've got post and rail type construction for a chair leg or a table leg, for example. A couple of small operational hints. Firstly, when you're making this sort of joint, always make the cut, pull the saw back, and then move your piece of wood. Don't try to move your workpiece while the saw blade is within the trench itself. And secondly, if you find it difficult to inch the wood sideways as you're doing the cut, then try this. Park your hand right there so that the edge of your hand is levering against the bearing channel, and then use that as a reference point and a steadying point so that you can lever incrementally across and make the cuts very neatly side by side. Another operational hint, if you're making your trenches and they're symmetrical, for example, one there and one there, the same distance in from the ends in both cases, then you can fit your fence to the work centre, reverse the fence and fit it as a stop, and then you simply butt the work up against the fence, make a cut. Then you would reset the fence by the width of the trench that you want, and make another two cuts, defining cuts. They're the outermost cuts of your trench, and then simply remove the waste. You'll notice there's no problem when doing a trench like this of pulling the saw back, because you're not actually creating a solid offcut which is going to be trapped between the blade and the fence, because this part is still connected to the main piece. So there's no danger of recutting that offcut on the pullback. If you have a saw which has a very long base, then you may find when doing a trenching cut that you end up with a slight curvature at the end of the cut following the radius of the saw blade, the curvature of the saw blade. There's a very easy way of rectifying that, and it's to fit a couple of fence packers to your work stops. They bring the work closer to you and eliminate that curvature. Let's say you want to house a board into a beam, and the beam is too tall to normally fit between the table in a normal position and the aluminium bearing channel. Well, no problem, you simply drop your table. Before dropping it, make a mark there, and on the front end of the machine to tell you where to reset your table when you go back to normal position, but then simply drop the table equally at all 4 points until you can admit your tall board, and then you can do your fine-tune adjustments for the depth of the trench by using the saw adjuster itself. A safety point. When using a tall board like this, we do strongly recommend that you fit extension fences to your work stops. They give you plenty of vertical support as well, of course, as a sighting notch. The work centre will give you a crosscut capacity of anywhere between 450 mil and 600 mil, 18 to 24 inches, depending on the size of saw you've fitted, the length of the saw specifically. Now, there will be instances, no doubt, where you'll have a board which you want to cut in the crosscut mode, and it simply won't fit because a saw blade gets in the way. Well, there's a fairly simple way of making this cut, provided your saw has a very smooth and yet firm rise and fall action. Every saw can benefit from a little bit of lubricant sprayed on the slotted arm, and some saws, in fact, may have to have a larger washer inserted between the clamping arm and the slotted arm or the slotted bracket. But make sure your saw can rise and fall smoothly without too much wobble as it's rising and falling. For that very reason, we do not recommend that this cut be done with a vertical lift saw. The problem with a lot of vertical lift saws is that they only tighten up when they're finally clamped, and that sort of wobble as you're plunging down, because that's what you'll be doing to do this cut, will throw you out in accuracy and perhaps cause a safety problem. So this cut should really only be attempted with a saw that has a firm action. Very simply, all you do is you raise the saw blade, like so, lock it in position your wood underneath, sight down from above, and you can actually lower the stationary saw blade onto the pencil line you've made, position your wood finally, close the guard, then raise up very slightly, switch on, and there you can cope with a wider board than you can normally cut. What happens if you've got a very wide board, up to in fact 27 inches wide or 675 millimeters? You can do this very same thing, a plunge cut, but you'll be doing 2 plunge cuts, because even with 1 plunge cut you would still have a small section uncut of the material. Before doing this cut, make absolutely sure that this edge and this edge are absolutely parallel, because they have to be. Raise your saw blade again, position the wood underneath, line up your blade with the pencil mark, again switch on using the trigger and then lock off once you're in the down position. When the saw has stopped, raise the blade, move the workpiece out, turn it end for end, and this is why it's important that these edges be parallel. Park the wood back in the approximate position, line the saw blade up and drop it down into the cut you've just made. Drop it down there, finally position your material so you're not deflecting the blade at all. Move it backwards and forwards, that feels fine.